In this video, I'm going to show you how you can simply and easily find the pivot columns of a matrix. And to do this, you first need to understand row echelon form. That is the key to finding pivots. So there is two rules that you need to be aware of. The first one's really simple. All rows of zeros must be at the bottom. So for example, this matrix is in row echelon form. One reason why it's in row echelon form is because the row of zeros is at the bottom. You won't always have a row of zeros, but if you do, it has to be at the bottom. This one here, however, is not in row echelon form because you have a row of zeros in the middle. So you'd have to change that matrix to get it into row echelon form. The second rule is a little bit more complicated, and that is that you have a staircase pattern of the first non-zero entries in each row. And this makes sense when you actually draw it out. So we're going to look at this matrix on the left. This is in row echelon form. So we need to find the first non-zero entries in each row. So we look at the first row here. This is the first non-zero entry reading from the left to the right. Then this is the first non-zero entry, again reading in this direction. On some arrows, and you can see that this looks like a staircase. And what we actually mean by staircase pattern is that, say you've got the second row, this is your first non-zero. The non-zero in the row above is up and to the left. So you can see that you're getting a simple staircase forming. This, however, is not in row echelon form because you don't have the staircase pattern with each row having a non-zero element in the row above up one to the left. So if you draw this on and find all of your non-zero elements in each row, so these are the first non-zeros in each row, draw on the staircase pattern, and it looks like this. However, this isn't actually a correct staircase pattern because of this bit here. This is dropping down 2, and so this here is your third row. You should have the first non-zero here to have a staircase pattern, but you don't. So this is not in row echelon form. So you have to be careful and make sure you have this correct staircase pattern. You don't want any drops like this because that's wrong. So this should have to do further work to actually get it into the correct form. And we'll look at how you can do that. Now, the really important bit is the relationship between row echelon form and pivots. The key here is that once you've got it in row echelon form, actually finding pivots is going to be really easy because they are very closely related. And the basic definition is that in row echelon form, the first non-zero entry in each row is actually a pivot. So here we have a matrix that is actually in row echelon form. Here is the first non-zero. Here is the first non-zero in the second row, and then the first non-zero in the third row, and then we've got a row of zeros, which is correctly at the bottom. This is in row echelon form because we have that staircase pattern. And the circled things in the matrix, these are actually your pivots. You have a pivot of 1, and a pivot of 4. We then need to extend this to look at what the pivot columns are. And pivot columns are really simple. Pivot columns are the matrix columns in which a pivot appears. So there's a pivot here, this is a pivot column. There's a pivot here, this is a pivot column. Again, there's a pivot here, this is a pivot column. So you have columns 1, column 3, and column 4. They are your pivot columns. It is really that simple. So let's look at how you can actually find pivots from a given matrix, and we'll do a fully worked example. So you have a matrix here. You should immediately notice this matrix is not in row echelon form. So to be able to find the pivots and the pivot columns, you need to put it into row echelon form. And so the first thing to notice is that here is one reason why it's not in row echelon form. You'd like to have a 0 here. So you can get that very simply. Row 2 is going to become row 2 minus row 1. So I've copied everything that's not changing. Row 2 is becoming row 2 minus row 1. So we're doing 1 minus 1, giving 0. Minus 1 minus 2 is giving 1. And then 2 minus 1 is giving 1. We're getting slightly closer to row echelon form. The next thing I'm going to target is here. And if we can get this to be a 0, that would give you row echelon form. And so what we're going to do to achieve that is row 3 is going to become row 3 plus 2 times row 2. So we've got this bottom row blanked out so we can work it out. So we're doing row 3 is becoming this plus 2 times the row above. That's giving 0. Minus 2 plus 2 times 1 is giving 0. And then 2 times 2 plus 2 times 1 is giving 4. And so this is now in row echelon form. And we can see that because you've got the staircase pattern, and you can simply circle all of your pivots. So we have a pivot here, we have a pivot here, and we have a pivot here. Turns out that all of the columns are actually pivot columns. So our pivots are 1, 1, and 4, and the pivot columns are column 1, column 2, and column 3. So that is how you find your pivots. Simply get it into row echelon form, and when it's in row echelon form, it's extremely simple to see all of the first non-zero elements, which are your pivots, and then the columns that they appear are your pivot columns, and that's you done. So hopefully this video was helpful to you. If it did help you out, please subscribe below. And finally, thank you very much for watching.